Assalamu alaikum everyone. So we will start today's session about the discussion on how we can decide how to make graphs. The objective of today's session was to understand the background about how you imagine which type of graphs are used in what scenario. So in the first session, I will start with some data background, and then I will give you some graphs, the discussion about the graphs, and then we go towards some practical exercises. Okay, so I will start with an overview. So when we talk about graphs, it means we are talking about visualizing a data. Okay, so we start with the data. Okay, so first is that we should know that what is data. Data is anything that can be recorded. Okay, anything that can be recorded using the modern tools, human common sense, or, or or any digital tools that we already have. So does not necessarily mean that it can be numbers. It can be what you call it, alphabets, sounds, videos, screenshots, writing styles, moods, specific measurement, maybe specific sound pitch, a specific color intensity. It can be anything. Okay, now I've seen computers, they can also record the smell also. Means they are able to quantify the smell into some characteristics. So it means, so and then if it is multiple dimensions other than numbers only, then it means it is also called then, if I add a notepad here, so if I click here, insert, and from shapes, so if it is open to record anything, and if it includes other than numbers too, then we can call it big data. Okay, but if it is only numbers but may have multiple groups, then it will become a multi-dimensional data. So we start with data. So data is a set of information that is collected for a specific purpose. So it doesn't mean that we only record numbers. We can maybe record a camera. It can record the movement of people. And then it can have of two major types: qualitative, which is also known as categorical, means there are certain categories and you don't know between the categories. That's why it is called categorical. Then it's quantitative, which is numerical, means it can be numbered, and then it can be compared. So the data reported from in non-numerical form is categorical, and in numerical form is quantitative. So examples of qualitative is marital status, political party name, eye color, favorite color, favorite day, month, favorite season. So these are some alphabetical forms. And the problem with that, why it's called categorical, because if you have two categories, you cannot find the in between category. Means you don't know how to measure them, or how you don't know how to compare them. So what are the limitation of the categorical data? Let's add some points here before we move forward. So it can eight two entries cannot be compared. We don't know which one is better or which one is not better. Okay, and a third entry slash new data cannot be created from two data points. Means without any certain information, we cannot get the third data. Means we cannot calculate the mean value, we cannot calculate standard deviation, we cannot calculate their sum, their cross product, their division, their multiplication, any process we cannot apply. Then in quantitative, there are two types: discrete and continuous. So discrete are those variables which usually are in whole numbers, like number of children, number of people present, number of people employed, number of people unemployed. So this data is the data which is usually counted items, means they are based upon the count, how many. And the other way is that it's all related to its units are human beings, like number of people employed, number of people present, number of people failed, number of FIR reported, number of prisoners captured, anything that is related to humans or anything that is based upon the count is discrete. So what is the limitation of the count data? That I will add a box here again. So when you're talking about count, so it means I will write little bit here. It means that we cannot go in decimal places. If we are able to create any new form which can go into decimal place, that will become the continuous data, not discrete. For example, percentage of children, percentage of defects. So that's a new form. It will not be discrete anymore. It will become continuous. And the continuous are data set those which are measurement based and which can go into decimal places. So it's a continuous data. Okay, so this is data based upon the variable type, means what kind of variable we have. Next is that other details like quality data based upon it will be shown in terms of names or labels, and quantitative data is based upon measurement value. So in any software, you go if you use any software, when you uh, see the imported data, you will notice that uh, it has if it is in numerical form, it means it is a quantitative data, and if you want to use the qualitative form, you have to code it. Okay, so this is the difference. Then we go to next slide. Then the other type of data is called data based upon its measurement, or in other words, I used to say uh, uh, used to say how much information is there in the data. So it talks about the level of information. So we start with, so there are three types of information. Let me add some background. So first type could be that it should talk about intensity, how high or how low it is. Then it should talk about comparison, if it is better or worse. And then third, it should allow arithmetic operations, means you can add two numbers to get the third number, you can multiply two numbers to get the third number. So can you do this? So we start with the first category. This is called nominal data. So if we have a nominal data, let me get a box here. This is data which has the lowest level of analysis, like your favorite, your maybe names. So or favorite color. Okay. So if we have this data for whole class, what is the maximum that we can do? We can only if we have like 500 students and we get the data for favorite color, what we can maximum do? The maximum we can do is we can say which color is majority, means which color is selected by the majority of the people. Okay. Other than that, we cannot do anything. So it has minimum level of information. We can maximum have that there is some intensity that the red color is selected by the most. So it means red color has the highest intensity in terms of being a favorite color. Okay. Say, but if there are two colors which are have the majority, then the problem will be we don't know how to decide which is better. So we will say that in majority there are two favorite colors. So this is one problem that we usually face when we have nominal data. Next type is ordinal data. Ordinal data is usually the data which is available in the numerical form, but it's in essence is measuring some qualitative ranks. Like military ranks, seniority of the faculty, okay, seniority of the family member. So this is an ordinal data. So uh, so it means like your grades. So let's say we collect the data of grades of the students. Some has reported A, some B, some C, and some D. So we have this data A, B, C, D. What maximum we can do is we have another extra information here is that A is better than B and B is better than C and C is better than D. But we don't know how much because we don't know how much person with A will be happy as compared to how much person B will be happy. We cannot find the difference between their happiness because it's just a rank. We only know A, the student that who got A will be more happy than the B, but we don't know if the happiness of A to B is same as B to C or is same as B to C. So in this information, so we only have a little bit of comparison, but we cannot apply arithmetic operation. Like we cannot say that A minus B will be equal to C or 2 multiplied by B is equal to A means two B's are equivalent to A means if you gave two B's to a student, he will be as happy as one A. Or if you give him three C's, he will be as happy as A. We don't know or we cannot measure. So this is ordinal type. Okay. And then we have a ratio or interval data. Usually in some books, there is no difference between ratio and interval, but in other books, they differentiate between ratio and interval. But for the case of graphs, there's no difference in terms of deciding what type of graph we need to make. So here, I am not differentiating that, but I might discuss it along the way, give you some examples. So the ratio or interval data is a data where you can calculate the difference between two numbers. Like your, so we can apply highest. It has highest level of information. You can apply complete analysis, which is here. So what can be the example? So let's come here and if I pick up a shape. If I talk about the GPA, somebody has 4 and some students have 3 GPA, some has 2 GPA, some has 1. So I know that 3 plus 1 is equal to 4 or 2 times 2 is equal to 4 or 4 minus 3 is equal to 2. So I can do the difference analysis or ratio analysis. I can calculate ratios, means the differences technically. So it means I can so if I summarize that in the nominal data, I can maximum is do the count or count the majority or to show a histogram. So I'll start giving some examples. So in the nominal data, maximum that I can do is create a column chart, which color has how many representation. Ordinal data, still since we cannot compare, I can make a column chart, but what I can also do is when I'm making a column chart, I can arrange the entries of the data x-axis values in increasing order or decreasing order so that I can see if the number of observation in each entry, does it follow a pattern? Okay, so I can do that analysis. In ratio level data, if it is numerical, then I can make, if I can make a line chart, I can make a column chart, I can make anything, that depends. Now, here I will give you another example that usually you see a histogram that you see in different data in books. So I will start with one major type of data graph type, that is a histogram. So what does histogram do? Usually histogram is different from other graph types because all of the graphs are trying to explain or increase the explanation of the data by giving more details. Means it can compare with other variables. It can go deep into the patterns. But the histogram is opposite, in which you have a data, you convert it into groups and then make a column chart. So it means you convert the data into ordinal data and make its columns. So since the ordinal data is there, but we know the differences because we made it from the continuous data. That's why we don't make column chart, we make histogram. The difference between column chart and histogram is that in the histogram, the columns are connected with each other because there is no gap between the data because we made the graphs in that way. But in column chart, since it's a nominal data or an ordinal data, we don't know how much distance is there in between or does they have a distance or not. So make a column chart. So this is a basic background. Now let's go to the final type and then we start discussing about the graphs. Last type is based upon data structure. It can be time series data or cross-sectional data. So time series data is a data which is data observed across time. So it means technically time itself is a variable. So we have time or a reference value which is actually changing across time itself is a time and we have a data. So it means technically we are studying same entity again and again over the time. So we technically we have two types of columns. One is data, other is the time periods. So it means you can make two variable graph in this case. Cross-sectional data. So in the time series, the time is actually a continuous variable if you know that there are no gaps. But if there are irregular gaps, then it can be shown as an ordinal variable. For example, first observation is 2000 and second observation is 2005. Third observation is 2007. So the first two observation has 5 years of gap, but the second has only 2 years of gap. Either you make a graph in a way that the columns are showing their distance, or you make it like a column chart. For example, I'm trying to calculate the data of GDP on each year when there was elections. So technically, it's a time series data, but the elections are not occurring at equal distances of 5 years. So what I will do, I will so technically my time period has a name. It's there. The name is the election name or election number. So what I will do, I will plot like an election number. So it will look like a time series data, but I cannot make it. I should not join it because I don't know how. I know the different distance between each election year, but if I want to represent it as a graph, I will make a column chart. But if it is a year data and it's a continuous years, I can make a line chart. Cross-section data observations are several entities as fixed point in time. It means I have two columns, data and cross-section name. So since cross-section name is nominal data, it doesn't have any representation. So what will happen is that it should be a column chart. So I will make an example that so our time series data is a data where we study Atlanta for 4 years, and the cross-section data is a data where we study 4 cities across 2003. So this is the way we talk about the data. Okay, up till now, if you have any questions, you can raise hand. Otherwise, I will now start towards making cases, and so that you can understand how the decision of graphs are made. If you have any queries, do let me know. If not, just can write in the message or give a thumbs up if there is an option. Okay, so I will now go towards discussing graphs. So I will share another screen now. So in the first set of 40 minutes, before we close, the meeting will be closed. I will cover the discussion part. In the second set, I will show more complicated examples. Okay, so let me share the screen for other topic. So I've shared you this file in the group also. So it has given it gives a very detailed examples, and I will show you overall, then and then I will tell you what's the advantage of this slide. So it is talking about the data can be categorical, like city name, airline name. Data can be ordered, like the class of a plane, business class, first class. Data can be continuous, like months, distance, flight time, price. Okay, so these are some examples of data that it has shown us. Okay, so now it start to make. So when we study one variable, let's say we have only one variable and we want to visualize it. So we talk about examples. So if it is a discrete data, since we can only count, we can make a column chart, bar chart or a column chart, or we can make a dot chart or column chart with a benchmark. So benchmark itself is a level, like for example, if for example Parliament, so they wanted to pass a bill, so they will tell people to give yes or no vote. So technically, the yes or no vote are two categories. So some people will say yes, some people will say no. So we will have two columns in the graph. But according to Parliament, if it is a major change in the constitution, then at least if there should be two-third yes, two-third people should have a yes, so that the change can be executed. So it means there's a threshold that yes should be at least this much number so that he can cross. Another example can be when a student gets an admission into maybe coming from A or O level into a university, they count number of A's or B's or C's. So every university has some threshold that he should have one A in the A level or O level, whatever the requirement they talk about. So even though number of A's, number of B's, and number of C's are ordinal data, but they treat it like a nominal data. So you can talk. I gave you example of nominal ordinal data, but I was trying to give example for nominal. I think it's clear for you. So first type is that you just count the cases. It can be column chart or a row chart, or then it can be a dot chart, and then it can also be a benchmark. So if your categories are across the countries, you can plot on the map. So this can be a new chart. If the categories are categories have some other examples I will cover. So if the data is ordinal, then you can make a column chart and make sure that it is increasing or decreasing order. Okay, and they are not connected together because we don't know how much distance is there in between. So here $1, $2, $1 sign, $2 sign, $3 sign doesn't mean that it is it's saying that it's cheapest. This is medium, this is high. This is the signal to give how pricey it is. So it's an ordinal data. If it is a continuous, you can make a column chart, but you can also make a line chart because that the distance between 1 and 2 is same as the distance between 2 and 3. Or you can also make an area. So if it is integration or you want to talk about the sum area under the curve, then you choose the area. If you're talking about only the movement, then it is a line. So this is for continuous case. If you have any questions, you can raise your hand at this point. Okay, so this is one category, one type, that if you have one variable, how you present. So so in special also you can talk about this. So you can also have a threshold here. In the continuous data, you can also have a threshold here. So you can use the budget or threshold method in all cases. Okay. Now we talk about that you have two data sets. Okay, and both are categorical, or one is categorical or other is defined by the top. So if you have one categorical here and one categorical here, what you can do? So what you will do, you can make a matrix. So this is a matrix where students have given their favorite color and favorite season. So seasons is here, color is here. So you just count them and plot. So it is a matrix. Okay, and if if there is a two categories, you can talk about their share, how many are here and how many are here. So usually when you see studies, they use um, they make the matrix table, or what you call it, uh, to count the categories. They, rather than show numbers, they can convert it into percentage. So or what he talked about, percentage delta is the rate of change. Okay. So this way you can present. Another type can be that if there are two categories and they are opposite, like male and female. So you can talk about how many A's are selected by males and how many are females. How many A's are selected by A's and how many females. So this way you can have mirror bar. So this example is you can see this example in most of the population related studies, where they show upper quantile population size, lower quantile population size across males and females, or pow poverty rate in upper quantile and poverty rate in lower quantile. So these kind of graphs are shown there. So in one of the file that I've shared, there's an example of this graph for continuous variables. So other type can be that if you have two categories, since you have a count here, that's why you're making a column chart. You can make a circle based upon the size of the count. So it can be a bubble chart, two-dimensional bubble. This is the one-dimensional, this is two-dimensional. So how it is two-dimensional? First, it is showing the size of the data across two dimensions. So it is measuring based upon class and price bracket. So this is another example of discrete categories. Okay, so they are made from cross tabulation. So in SPSS, there is a process. If you have two categorical variables, you can make a cross tab, and if you have a cross tab, then you can make these graphs. Then if you have ordered data, so like you have two categories, male and female, and you have their grades, then you can plot like this. Okay, so you can make that how they are different from each other. So this is a categorical versus ordered data plot. Okay. And next is the example of slope graph. So let's say you have two categories, 1 and 2, and you have two numeric. You have three numerical data sets that are changing across the two categories. So you can talk about the grades. Grades of three students in course 1 and course 2, or maybe microeconomics 1 and microeconomics 2, and then you plot that which one student learned in both courses, or maybe master's grades, master's GPA and PhD GPA. So you can plot that did he improve the GPA or not. So technically the audit this is continuous matrix graph. So you have a continuous data compared across two categories. So the other example can be you are plotting the before COVID and after COVID GDP values of three countries. This can be done like this. Other example can be that you can see that there are three categories, and then you plot their price and distance. Like you can have, like, there are three houses and you're plotting the distance from the airport and the sale price. So you say that the houses which are where the distance is lower, or houses which which distance is lower, their prices are higher. Usually in developed countries, the houses which are near to airports are cheaper because of the noise. But for the developing countries, houses near to airport are expensive because there's an extra security, because there's an airport security and there's police. That's why houses are more secure. Third can be that if there are three categories, do plot like slopograph. So you plot how they are changing across three observations. So this is the second example. So if you have any questions, please raise hand. Otherwise, since the session will be closing, we will be joining again. So when it's closed, you can join it again. But I have another minute or two. If you want to ask any question, you can raise hand. Yes, you can ask.
Assalamu alaikum, sir.
Hi.
Sir, I want to ask that if instead of categories or persons, there are some particular countries like in panel data, and we want to compare their variables.
Yes,
So, can we consider categories to be the variables?
yes. So in their example, the country names are categories. So country
Okay.
names are categories, and then you need to decide which variable you want to compare. So what you can do is you can calculate country-wise averages in the panel data and plot like this example. Okay. Or this, if you have two variables like this, or even like this. So usually I do is that when I want to focus on the country differences in the panel data, especially when the panel data has few years, so that it's not dynamic panel data. It means my theory is coming from country differences. So what I do, I go in Excel or in Stata, I calculate the country-wise averages and plot the variable which is country-wise average, and then compare how developed countries and developing countries are different. I will show you one example here. Let me open it up. So you can see in this file, what I did, I wanted to get the problem statement that there's a difference between uh, Islamic and conventional banking. So I had the panel data for these countries. So what I did, I took the value of certain time period, okay, certain time period, and then compared. So I found out that majority countries have similarities, but other countries have disjoints, especially Bahrain. So and Kuwait and Malaysia. So from here, I found out that I tried to connect this with my problem statement. So this is an example that you can do. Okay, another question was which graph so I will discuss that in the after the break. Okay. Okay, we are back after the break. So I will discuss with the answer or the comment. So which graphs are specific to time series cross-sectional panel data? I mean, which we can assign. So technically, the graphs are not designed for a specific data. The limitation of graph is that it has two axes. So you need to decide what you want to put and where. So if it's a time series data, your time will be one axis and the variables or one variable will be on the other axis. Okay. And if it's a cross-section data, then the cross-sections will be on the one axis and the variables on the other axis. And then how you arrange it, we'll discuss. So for the case of time, we know that since time is a continuous data, so other variables are definitely also continuous because you calculate it at country level. So it should be a continuous data or numerical data. So since both are continuous, then you go towards the line chart or another type. If it's a cross section, then by definition, one axis is nominal data. Then you stick to column chart. Maybe maximum you can go to comparison between developed and developing countries. So you split them. For the panel data, since it has third dimension, and then what you can do is, I give you one example right now that you convert the data, panel data into country-wise averages and treat it like a cross-sectional, or convert it into time series with the one which I will give you example in here below. So if anyone has a question, you can raise hand or ask. Otherwise, I will start with the other example. So the next example, it is showing when they have two categories. So rather than you make a matrix, you can make a multiple column chart like this. If you have you have different benchmarks, so you can make like this. Okay, so you count that how many x's are there and how much y's should be or not should be there. Or rather than you make bubble plot, you can make a color based upon the value. So bigger the color means darker color. So you can make a heat plot. So if you have two categories and in there, if their two variables don't have same axes, you can split them. If three lines don't have same axes, you can split them into separate graphs or move one of them to secondary y-axis. So this way you handle one continuous and one categorical with other categorical, other ordinal, or other continuous graph. Okay. Then we have other example. We start with this. So we have a group category. Means there's a categorical data, but the sum of all categories, they are exhaustive. Means sum of all categories is known. Like parliament, number people in the class. So you can make a pie chart or stacked row chart or stacked column chart. Okay. Or if it is if your data is ordinal or it can be continuous. So it's a waterfall chart means it's event A, they have this much revenue. Event B or month B, they got this much revenue, but month C, they got this much loss. So this is a different time event or categories or sale campaigns, and this much income, and this is loss. So this can be used to do the comparison. Okay. So next is if you have two categories, you can also make the two categories, but you have what you call it, other categories also there. You can make a multiple pie chart, but it's confusing. You can make a stacked column chart. So it converted into percentage. So it tells us how much A's are there in X, how many B's A's are there in the Y, or how many A's are there in the, or how many X's are there in A, how many Y's are there in A, and how many Z's are there in A. So you can go other way around. And then there is another type of graph that is called Marimekko graph, where the it is two-dimensional now. Here it was only telling how many X were there in A, but not how many A were there in the X. But in this graph, the columns are showing how many C is there in the Z, how many B is there in the Z, how many A is there in the Z. And it is also telling in terms of thickness how many X is there in C and how many Y is there in the C, how many Z is there in the C. So this is another way. So last is if it's ordinal, it looks like similarly, but it is in column form. And in ordinal, you can also join it with lines to show that it is continuous, it is connecting. Okay, and then it can be line chart or stacked area if there's a multiple categories. It was one category, group of categories. If it is hierarchy, so you can make a tree map or you can also connect. So hierarchy means you can break out. So you can say that within A, there are further three types. Means there are two categories, but category number second is subset of category set one. So then if you have hierarchies, you can make scatter plots. Okay. And then this is all the graphs based upon categories. Focus on how categories are connected to the other type. So if you have any questions here, let me know. Otherwise, I will move forward for some other example. You can ask a question here if you want. So this is the data set, and I have opened it in Power BI software. I'm using Power BI because it is easier to make graphs here. First of all, because it can easily be connected to live data, and because of its connection, and you can make live graphs, means that you can see the subsets of the graphs. So I have a data for some type of companies across America and Europe, and there are multiple variables here. Some have data, some don't have data. So this is here. So I will show you some examples. So I have converted this data into categorical. So I will go into the report view. So see, first example that I did, I have the continuous panel data, but I converted into I've extracted one nominal data information. That is how many companies are there within specific sector or category. So technically, I'm presenting a nominal data which was available within panel data. So it means nominal data and panel data can exist together. Means a specific variable within the panel data is a nominal data. That is maybe number of countries in your sample, number of years of data for each country in the panel data. So I can present number of years, but I presented number of firms. So this is an example for presenting nominal data. So you can present it like this. You can make a column chart and add the labels. You can do it in Excel, and this way you can do it. Let's see. So first thing about first advantage about Power BI is when you make it, you can also hover on it and you can see more details. I will show you what are the other advantages, that in the filters you can add another variable and see how does filter change. For example, if I see in a data, let's say, let me see which data set it has used. It has used the firm count data. So in this data set, in this what I did, I converted the data in terms of um, averages or count values across sectors. So let me see if I can understand any particular data that I want to use. Density. So let's say if I want to pick up the profit value, let's say if there's a profit data set, number of research, net income. Okay, so I select the net income as a filter. So I wanted to only show the profitable companies. So I only select the positive numbers and not the negative numbers. So this way it will show the graph for those companies which are profitable rather than companies which are facing loss. So this is an advantage of Power BI, that you can, now what I did, I am plotting a nominal data, but filtering it using another nominal category that is having profit or non-profit. So it's a nominal data compared with another nominal data to get a new information. Okay, so I'm just it will there are too many values. Technically, I should calculate a new variable which should be zero if it's a loss and one should be positive, and then I say that only draw if it is positive. So I can easier ways advanced filtering, and if I say it should be uh, I can have more filters here. So this is one example that I wanted to show about Power BI. Let's move forward to another example. Let me remove this filter so that it does not disturb later on. Let me remove this filter from here. Okay, so this is the normal graph. Let's move to second one. So this is continuous data, carbon emissions. So let's see if you have a question here. Okay, so how graphs are made in Power BI? I will share you a link of how to import dataset in Power BI. Okay, so what I did, I imported a dataset, and you can see there are 5 or 6 datasets here. So original dataset is this, but what I did, I calculated like year-wise averages, country-wise averages, firm-wise average, sector-wise average, firm properties, firm count, year-wise comparison. How I did in Power BI, there's an option of creating new data set using Power Query. So I created the new sets. So when you create new data set, then your data set becomes interconnected. We call it the relationships. But for Power BI, you can look at the videos in my channel and you will get the details how to make these data sets. So all the data sets are connected to each other because they are made from the original data. So now I am only showing the sheets. And when I click it, it tells me which data set it is used for the graph. So if you see here, let me close. It is showing that this data is used. So what is here? It's a carbon emissions data plotted across the countries. So what it is, it's what I did, I compared the nominal data with the continuous data by calculating the country averages because I cannot plot multiple values for each country. Similarly, this, what I did, same value, it's emissions across. So what is the difference between this and this? I will start with this. This, between this and this, there is a minor difference in the way what I want to present. In this graph, I wanted to show the differences or only how many representations are there. But the sum of all of these is equal to my sample size. So I could have made the pie chart also. But in this example, I wanted to show that this is the total carbon emissions and I wanted to have a comparative share. So here it is giving me number along with percentage. Here it is only giving me number. So since I don't want to see what are the percentages because that does not matter in this example. But in this example, the percentage was important. So I did a pie chart. But still, it's a ordinal data, categorical data compared with continuous data. Okay. Next example, what I did here is same as the Excel file they showed PDF. So it's an ordinal data, nominal data compared across 3 continuous data. But I know I wanted to see their relative form, their total percentage. So I saw out that in the technology category, variable A has this much percentage, variable B has this much percentage, variable 3 has this much percentage. So I am getting the relative percentage of 3 continuous variable across the categories. So this way I can compare. So this is another way. Then again, another variable country-wise chart. So when you make a country-wise chart, what other sometimes people miss is that when you have a country-wise chart, you color the categories, but you don't color the categories in an ordinal way. If you color them ordinal way, it's easier to read. So I know that lower number is good, so I gave it a blue color, and the higher number is bad, so I got it red color. So in Power BI, you can do it by when you click the graph, you can go in the details format and you go for fill colors and you decide which color you want to give. So bigger color, I gave it a red color, and for lower, I should give green, but in this there is no green, so I stick to blue. So this way, it's a ordinal country name, a nominal country name compared with the continuous data, but presented in an ordinal way. Okay, so that there is an extra information that you can get out of the data. Next is similarly a country graph. So this is only a table. There's no graph here. And next example, yeah. So in this graph, what is happening? So I have a time series data. How I got it? I converted the data into country-wise averages. If I click it, it will tell me year comparison data set is used. And I'm comparing 2 variables. And one is here and second is here. Why? Because they both don't have similar scale. So I moved the other one into the other side. So this way, what is happening is you can compare the time evolution of two variables. So if you are studying causality or if you are studying behavior, time series behavior or non-stationary behavior, you should make graphs like this. And in this graph, since I don't had any more variables, I cannot do any comparison. Okay, but I can do by adding a variable in the filter and making it into two categories, low value or high value. So you can notice that generally they have a positive relation, but in the last few years it has a negative relation. You can present it that see there's a debate that what is the reason behind these 2 years. Maybe it's after COVID, the behavior has changed. Okay. So anything that it should connect with your problem statement or such question or such hypothesis. Now let me see other if I have more examples. So see, I converted the age of a company, which is a continuous variable, into a histogram. So it shows me that how many companies are which size. So uh, there is only like if I am able to connect. So there are 12 companies which have age 130 years. Okay, 19 companies which has age 120 years. Okay, so this is the data. So you can make a histogram. Same example is here. Same thing. What I difference is this that in this graph I was able to add class boundaries, and I have made a video on this also to how to add class boundaries. But there was a limitation in Power BI that when you make a graph, histogram is not able to show class boundary. It is only showing the class starting value, not the end value. Okay. So C is 60 and this is 50. So it means this column is 50 to 59. So we don't have that value. Okay, I will show you another example. Last one from this slide. What I did here is that there is one histogram that I already discussed. What I did that I split the data into two groups by converting one continuous variable into categorical variable. So I said that if the capex to depreciation ratio is negative, it should be 1, otherwise 0. So I was able to see how many companies are there in the sample which have capital depreciation negative. Capex to depreciation ratio negative means their depreciation rate is higher than less than 1 means higher than uh, the capex. Okay, so let me complete it, then I will go to the question. So in the next net employment and then operating margin. So what is the advantage of Power BI here is now since I have multiple graphs shown here. So if I click any category, like I wanted to focus on this, if I click this, it will show me this subset only. So see the changes in this graph. So if I select this, it will show me the other subset. So if I press escape, it will come to normal. Yeah, if I want to subset this, it will show me the subset. So that's the advantage of Power BI. So you can explore multiple differences and then create a story. Okay. Now I will come to the question and then we'll go towards more examples. So when we have large number of countries, which one is the best suitable? I have many papers you see in line. So you're saying that you want to do plot a time series chart across the time series chart for the countries and they're jumbled. So usually if there are many countries, I usually avoid creating multiple line chart because they are not readable. What I usually do is I make overall time series chart across the variables just to see if there is a generalization pattern. So if it's a panel data, the generalization pattern should exist or a debate should exist in the generalization. If you are also exploring across the countries and your countries are many, I would recommend go towards subsector, means a continent-wise graph, or maybe developed versus developing, or high income versus low income, means find some subgroups. Otherwise, it's not easy to plot them because sometimes a variable don't have similar units. What I've seen in some studies that they have tried to make it in a different way, like in a spider plot, but still, if you have too many, it will not work. So I usually don't do it. Uh, because it will create more confusion. It's useless to show it because you cannot tell which line is for which country. I've seen in some papers what they did uniquely is they make line chart for all of them, but they show them in a gray color, and they only focus on few countries which are highlighting the problem statement or the theory of the study, and then label them also. So we have a background as a shaded lines and few lines which are colored. So this way you can do it. And that you can make in Stata or even in R or Python. If you have any other questions, you can ask now. Otherwise, I will move forward for other examples. Please raise hand if you have any questions. So this is one example of spider plot. What the problem was that I had three variables which I needed to plot across the countries. So if I make a column chart, there will be too many columns. It will be too wide so that the column thickness will be very narrow and it will be not readable. So what I did, I present it in a way that it is a spider plot. So you can now have a comparative view from minus 0.2 to 1.2 and see how each value is changing. So here you can see blue and green are more stable as compared to the red. So this way you make a spider plot. It can be countries here and time in the axis. You can make like that. Another example I showed is this column chart where there's a column and there's a count and there's a threshold. So anything that is crossing the threshold, technically this is a threshold from some other data and the color is from some other threshold. So you see there are two thresholds shown here. Other example that is here in this graph that I wanted to show was, see what I did because I wanted to show that my data has different correlation across the countries. And I created two types of factor analysis. Okay, so what I did, or another way, I have two variables which I wanted to see their distribution across the countries. What I did, I plotted their box plot across the countries. So I can see how variation means the distribution of each variable changes across the country. So there is a certain comparison that can be done across the countries for two variables. So this can be done. Another example I wanted to show was in this graph that I shared why I usually make a line chart across the time or across the cross sections. So this is current account versus profits across Islamic banks. So I wanted to create a debate that see for the example of these two countries, they had a high profit, a high current account and high profit. Okay, and but in this example, it had low current account but high enough profit. So it means, and I discuss more examples like one example, this one. So from here, I debate that my data is showing that it is not conclusive that does current account lead to profit or not. So from here, I suggested that there is a non-linear relationship. So then it connected to my research objectives, research hypothesis. So this way, even though I had the theoretical background also, but I tried to give the answer using empirical evidences. So created a problem from the empirical data. Another example I can show it here is, let me close this one. Close it. Yeah. So in this example, I wanted to show you, let me go down. So in this graph, I added one more thing. That while I'm comparing the distribution of two variables, I also mentioned I also commanded R to give me the correlation between these two variables. So for each comparison, I also have the correlation value, how correlated these two variables are for this country. And then I also provided the overall correlation value in the title. So I converted, extracted some. So technically there are 3 or 4 informations: the associations, the distributions, and the patterns. So multiple things in same graph. So this is similar, and I think there is yeah. So this is also a spider plot made in Excel. So there were multiple variables across time. So I plotted like this. It's not very good readable because the dots were colored. It should be using space, but still it can give us a pattern. Okay, see. So this way I make a spider plot. Last example for this batch is that I can make like this. So you have a scatter plot between 2 continuous variables, and then a third variable is converted into boundaries, and then I colored it. So this is made in Stata. So it is showing me that generally there is a negative association between 2 variables, but in this association, this variable, if it is high, it this variable lead. So it is telling me a moderating role. So this way I usually justify my moderating role. So this is telling me that 80-80 variable is a positive moderator, because when 80-80 is higher, usually the dots are above the line. It means same labor are leading to higher GDP, positive moderator. So same thing 80-RT, same thing, and it's a mixed, it's FWD. So it has negative moderator, means lower value is on the upper side. So PAP, higher value on the upper side. So this way I'm justifying the PAP as a moderating variable. Okay, so if you have question here, do let me know. Otherwise, I will try to go towards explaining 3D plots. Okay, so yeah, so you want to share codes? Yeah, so since I'm trying to show you graphs from multiple sources, so you can share in the group which graph you are talking about. I can share you examples. Otherwise, if you want to make it in R, I will show you on one library which I usually use to make the graphs, and even in Stata. But since I recently learned the Power BI, which does not require coding, sometimes if the data is very big and there are too many ways to make graphs, I usually do Power BI, because you don't have to remember the codes to make them. And sometimes when you make a graph and some subset or some filter is giving us better information and you want to explore it, Python Power BI is faster. Okay, let me think of some 3D examples and then I will share it. Meanwhile, you can ask any question if you want. I see in this paper, I wanted to compare the time series patterns of subgroups. So there were too many countries. What I did, I made the country-wise averages and then plotted that variable across time. So this way I am looking at it, which year they dipped and which year they increased. And if there are any differences, I can see here. Yeah, so you can use ChatGPT to get codes. So to make sure that if they're reliable or not, what I usually do is I get the code and try to run it myself to see if it gives the same result. If not, then I get the codes again. Otherwise, if I get, then I ask him to. So I inquire more questions to, maybe he gives me, ChatGPT gives me more ways to innovate it. So you can this way make the graph. So this is the example of spider plot. Okay, and this is the map for country map. I will show you more examples. Let me share. So the this session is closing in 1 minute. So I am closing it and opening it in 2 minutes, while I will also open the data, the examples that I want to show. Record. So now I will show you some more examples with interpretations of how certain scenarios are handled. in the graphs. So first example I'm going to show here is that in this paper, what I did, let me go down. Let me show you the graph first. This is simple scatter plot with linear fits. In this paper, I had the panel data, and the way you said that I needed to show you line charts, what you can do is you can make a graph like this. So you have a data and you add a trend line at the end. So there's a pattern. So this is data is actually my forecast values for next 10 years and then the forecast trends. So this way you can make a table if you want to make an appendix, especially in the thesis for your data. You can show like this. This can be done in Excel. Just select the data and make it a line in the X box. Okay. So if you want to discuss, I can discuss in the comments or in the chat later on in the group. You can ask me. I will give you demonstration of how to do it. Another example is that you can do is that this is what I do is because I needed to justify quantile regression. What I did, I calculated the quantile wise correlation. So I pointed out that the correlation value changes across the quantile. So it means the association is changes, so it might lead to changes in relationship also. That's why I did quantile regression. Here is example of uh, okay, you can ask me in the group that is made in the morning. I will give you an answer. So this is the spider plot. Here I added a benchmark also at the 0. So this is because I did the EMG model. So I needed to present the ECM value across the countries for 3 quantiles. So I need to see how many of them are between -1 and 0. So you can see other than one, few cases majority are below it. So there is convergence. So this way, and this is quantile graph for 3 percentile values. This is simple quadratic equation presentation. I just gave colors. Okay. Next example is, let me set it up. This example, what I did, I started with presenting the data as a comparative form. You can see, and what I'm doing is I am presenting data from three from different data sources, okay, and then ranking it and then comparing. So one data source, second data source, third data source, okay. So technically there are 4 data sources which are discussed somewhere here in the presentation. Only three are shown. Okay, then this is simple ordinal nominal values and then it is presented. So this way you can the objective of understanding graph is sometimes some evidences you can get from your data rather than the theory. So it can complement the way you write rather than you waste a lot of time in finding articles to justify your argument, but it is already present in the data. You can just use it. Another example is this one. Let me go up. So you said that if you have multiple data across time, how you can compare. So if there are not that many, you can make like 3D. So what I did, I converted the data into groups and then made it a 3D. So this way it's look more attractive and still it is comparable. Another example you can see here is that in the scatter plot, I separated the sample into 2 types and then added the linear, non-linear fit to see how does it change for countries which have renewable energy below the mean and above the mean. So it means I wanted to use renewable energy as a moderator. So if I see the estimation analysis, my estimation, I can see renewable energy is a moderator here. Yes. So, and then I plotted, you can see there is a flipping in the moderation relation. So this way you can present that. Next is another example. So if you come down, there's a simple overall line chart. And the unique example here is that what I did that in this example, there is a quadratic effect. with the variable, but since other variables and there is a moderator here. So I wanted to show the moderating effect. For this paper, I didn't know that there are other softwares that can make 3D graphs. So what I did, I tried to make it myself using Excel. So what I did, I calculated the marginal effects myself. So what I did, I calculated the moderating variable values, uh, and then used it as a color. Okay, so this it is showing that uh, how different values of my independent variable and different value of my moderator are leading to different effects of output. So output is in color. So this is technically a 3D plot, but using we call it a contour plot. I made it in Excel, and it took me a very deep calculations to show this pattern. Okay, but it can be done in Python and R easily nowadays. Next example is this paper. I wanted to show another example here. So let me go down. I was able to, so since you have three variables across the cross sections, you can make like this. One of them as a column chart and two as a line chart or any other combination that you want. So this can make it more presentable. But because these two are compared with each other and this is the net effect. So I wanted to show it differently. That's why I converted into lines. So this is another example. I will come to this graph at the end. Let me go to this example. In this example, what I did, go down. I was able to show two line charts. And then if you go down, you can see one more example. Yes. So this is the way you can present your data as that why you are doing panel data. So here you can see what I did. I made a line chart across the countries using the average of the dependent variable and then also presented the other dots, the observation. This is showing me that how the deviation between countries are different and the mean value of the dependent variable is also different. So you cannot run a panel data because if you want to make it a pool data, two things must happen. The mean value of dependent variable must be constant or the distribution of the dependent variable must be similar. Similarly, other dependent variable I made like this. So this way I confirm that the data dependent variable is changing across cross section. So I have to make fixed effect or random effect. Another example I wanted to show is, let me start with this one. In this paper, what I did, same contour plot strategy. So I came down and I had so I applied the quantile and quantile regression model. So this is the contour plot where I have different quantile values of IV and different quantile values of DV and their marginal effects. Okay. So this is the contour plot. Again, a contour plot. This is the same as what I showed in the Excel file, but more observations. So that's why there's more detail. And then all of them are made. So I made them in using MATLAB, but they can be made in R, even in Excel if you have the values. This is a type of 3D plot. Because if you make the other way, actual 3D plot, it is very difficult to print. It should be shown on website so that people can rotate it and view. And now go towards the actual 3D plots. I made it using MATLAB. So in this paper, I applied the quantile and quantile regression. I came down. I will give you its interpretation also this time. So same contour plot. You can interpret, you can see if CPI value is in the middle and the dependent variable is the high values, then the effect is dark blue. Dark blue means negative. So it means how you interpret. So for very high CPI, for all values of GDP, the effect is very high. So this way you interpret. And same thing is here. So this is control method, this is 3D plot method. You can see at high values of CPI, there is a peak here, but at medium values of CPI and high values of GDP, the lowest value is somewhere here. So this way you interpret the 3D plot. Okay. So this is the example of 3D plot. Last example I wanted to show was, it is more complicated. Let me see if I'm able to explain. What I did in this paper is that I was able to use all 4 axes in the data. Let me go to the data. In the graph, all 4 axes. So let me show you example. So what I did here is, firstly, I estimated a quadratic regression with a moderator and then plotted the moderating role. So you can see dependent variable here, independent variable here, and the moderator here. So it converted from U shape to inverted U shape. What I did next, I found 4 countries which are one example each from each percentile values of moderator. For example, France, whose institution values is 60 percentile. No, I found countries which are near to these benchmarks. So I found a country which is France, which has Islamic financial development around 20. Okay. And I found out that it is somewhere here because I found out that its financial institution is 60 percentile. So it should be here. So I'm going to predict that for France, it will have this much business density. Then I found another country, Singapore. It has around 42% Islamic finance, but it has 100% institutions. So it should be on the 80% institution line, percentile institution line, and should have these institutions. So this way, what technically doing is that this axis is plotting the country based upon the Islamic financial index value. It is making a dot based upon the benchmark percentile of institution value and then giving us the prediction. So a lot of calculation is done to make this graph. Okay, so these are some basic graphs presentations. So house is open for Q&A and for today's session. And what I wanted to, what was objective was to create awareness first. That's why I created a group. And the people who are listening to the video, they can also comment in the video below so that I can give you feedback how certain type of graphs can be made. So house is open if you want to ask, and I will try to answer until this meeting is going on. Then we will conclude today's session.